Hello, everybody. This is Mr. Kusaj. We're back with really the ending of chapter 1. So we did part 1. Now we're doing part 2 of 1-7, composition of inverse functions. So we already know what composition is. That's a function of a function. Here's a question. Let me go back to part 1 and ask a quick question. Remember this last example? So here's my original function. We already have this. Don't copy this. We already have this. Here's the original function. Here's the inverse function. What would happen if you do a composition of those two? In other words, a function of a function. Remember that? In other words, f of this function. You put all of this in here. Or the other way. Inverse f of this function. You put all of this in here. What would happen? Right? We know what would happen if we took any two functions and did that. We get a third function called the composition function. But what would happen if you start out with the inverses? Well, something interesting. You get x. So what I'm saying here is, if you do a function of a function, if you do a composition of two functions, and everything cancels, and you're left with just x, then you're dealing with inverse function. And it doesn't matter which way you do it. If you do the first one into the second one, or the second one into the first one, you will get x in both cases. You will see the example, okay? That's how you know that f and g are inverses functions. That means you can erase g and put f with a little minus 1, right? We didn't know that f and g were inverse functions. We didn't make them. But if you do this to them, if you do a composition and you get x, now we know that they're inverse functions. So the question would be, show that these two functions, one called f, one called g, show that they're an inverse function. What? You're going to ask me to find the inverse function of f? No, I'm giving you two functions. And I'm saying that they're inverses of each other. It's already done. But you have to show that they're inverses. Okay? So here is, now you got to know how to do composition. Here is f of x. Now, I'm sorry. Here's f of x, here's g of x. Now I want to do f of g of x. That means I take g of x and put it into the f function, right? I'm going to take all of this and put it right there. That's what I did. 6 over x plus 4 goes in there, and that's what I did. Now, if we do algebra, if we simplify, look what happens, right? The plus 4 minus 4 cancel, right? And we're left with 6 over x. How do you divide by a fraction? You take it to the top and you flip it over. So you get 6. Sorry. I keep doing that. So you plug in g of x and you get this. So now simplify. The plus 4 minus 4 cancel. So you're left with 6 over x on the bottom. So this says 6 divided by 6 over x. How do you divide by a fraction? You take it to the top and you flip it over. Remember that? So you're left with 6 times x over 6. And what is 6 times x over 6? Well, the 6's cancel and you're left with x. So I got x. Now that shows that f of x and g of x are really inverses of each other. Are really inverses of each other. I just showed the world that they're inverses. How? By finding the inverse of this and seeing what it is? No. By plugging one into the other and getting x. What if you plug this into this? You should still get x. Watch. Now we're doing g of f of x. So we take all of this and put it right there. That's what I did. Okay? So let's simplify this. So how do you divide by a fraction? It goes to the top and you flip it over. 6 over x minus 4 is x minus 4 over 6, and we multiply. Notice the 6's cancel here. The 6's cancel. So we're left with x minus 4 plus 4. And the 4's cancel, minus 4 plus 4, and you're left with x. Okay? I did it. I showed that f and g, these two functions are inverses of each other. How? By putting one into the other and getting x after simplifying. Okay? How do you show inverse of a graph? Okay, so never mind the algebra expressions. What if you're looking at a graph? All you do is reflect over the y equals x line, the perfect diagonal line, right? Here's the perfect diagonal line, right in the center, right? That's the y equals x line. So if you're asked to do it with the graph only, what you do is you find and draw the inverse by first, let me reveal the whole thing here. By first, so this black one was the original. So first, draw the perfect y equals x diagonal line. And then each point is like a mirror image, right? So this goes to here, this goes to here, this goes to here, this goes to here, this arrow goes to here, this arrow goes to the other side, right? And then just connect the points, and you have the inverse of the graph, right? That's what inverse means. The graph flips over this line. All right? Okay, so the try problem, page 68, 3A. Try that, and we'll start the class with the try problems when I see you next time. Okay, bye.